Hello. Hi guys, good morning. Welcome back to the video. Ki hal chal? I hope you're doing good. The video is a bit late because I reached a bit late. If you don't know, I was traveling. If you don't know, we had a live stream in the morning itself. We have a live stream soon, so do join us. Do subscribe. Now, in this problem, it is marked as medium, but it's actually hard. So again, why I say hard, I'll tell you. If you have not tried, I highly recommend go and try by yourself. With that, before even starting and taking the actual approach, I will tell you what I thought of, why it was wrong, and I will not spend much time on that. Let's start. It is simply saying that you are given an integer r in nums and the queries of I, li, ri. Now, each queries of I, it represents something which is range li to ri. It simply says that for each query, I can decrement the value at any index in this range by at most 1. Again, see, it is saying at most 1. So if the range, again, let's say the nums array is from 0 to index 8, my query li to ri is, let's say, from 1 to 4. Then I can choose indexes 1 to 4 individually. I can choose to decrement them by either 0 or 1. I can maybe decrement this by 1. I can maybe not decrement this at all. Decrement this by 1, like decrement this by 1, and like choose to ignore any element. This is the next line. The amount by which the value is decremented can be chosen independently of each index. For this query, I can independently decrease any value I want. So for this query 1 to 4, I can independently decrease it. That's the crux. Now ultimately you have to obtain a zero array. Zero array is an array with all the elements equal to 0. And you know the operation is choose a query, decrease the value in that range by 1. Now ultimately return the maximum number of elements that can be removed from the queries. So query, as you saw previously, it is nothing but range. So he's asking, I have given you 3 queries. Give me maximum number of queries which you can remove from this list of queries which I have given to you, so that still you should be able to achieve your final array after transformation to a zero array, right? Now, the first very basic intuition which comes to your mind is, before even going that, let's just simply see this example. Just one example. As you can see, input array is 202. Given array is this query. Answer for them is 1. I can maximum remove one query, and that one query which I will remove is this one. Because if I remove this one with these two queries, which means in the range 0 to 2, in the range 0 to 2, I can choose to decrease any value by at most 1. So I choose to decrease this by 1, it became a 1. I will ignore this index 1, I will choose to decrease this also, it became 1. For this specific query, again I will choose this entire range, this will I will decrease it to 0, I will ignore this, I will decrease it to 0. Ultimately, by choosing these two queries which will have to be chosen, I ultimately got a 0 array which was required. Thus, I for sure would be needing 2 queries, and thus maximum number of queries which I can actually remove or get rid of will be 1. This answer is 1. Now, if you haven't thought of what will be applied here, the first very basic intuition which could come to people's mind will be a binary search. On what? On the number of queries. Because I want to minimize the number of queries being used, so I will try to see that, okay, let's do a binary search on how many queries I will be able to achieve. But if you will do the binary search, the prime question will be that if, let's say, I'm doing, okay, let's say in the input range I am given 0 to 3 queries, I can choose to take 0 queries, or I will choose to take all 3 queries. If I choose to take all 3 queries, the queries which will be removed ultimately will be, if I choose to take 3 queries will be removed ultimately will be 0. In that range, you have to go and step on this range and tell, is it possible to achieve 0 array with choosing, let's say, 2 queries? But which 2? That is a very big question. Thus, binary search will not be applicable here. Now, other approach which could come to my mind, which could come to people's mind is, again, this is the first approach which came to my mind, and obviously I, at the first glance, rejected this approach. Next approach, because things are happening in range, there is a range based operation happening, so folks can start thinking about range based queries, and on top of it we might start thinking, okay, I now have to approach this problem by removing some queries, so maybe let's greedily try to remove some queries or try to take some queries. With that, when I say greedily, you know that there is one such query. Now for a query to be used, I will judge it on the basis of its impact, or when I say impact, I mean how many queries are overlapping on that nums of I. Again, these words are very much critical and it's not an easy problem. So listen the wordings which I'm saying again if you don't understand it, right? So either the impact as in queries are overlapping and thus will represent the amount of impact which can be given to nums of I with the help of queries, or the length of the query. Bigger the query length, bigger the actual impact in the range. Thus, what I was thinking of is, can I make a heuristic function, as in kind of a function which will take both of these in consideration? So I was going in a bit mathematical terms. And the worst part is that I was not even certain. I was applying greedy, I was building a kind of a formula which could incur both these things. And thus, if I show you my code, this is what I wrote. So if you don't know that, we had already given a segment tree template, so I use the exact same template of my segment tree. So this entire portion is actually my segment tree template. And then the actual question started where I actually went on, build a function, like build all the queries, then tried to build a heuristic function kind of on the basis of length and extra, and then I went on tried to remove it, going greedily but kind of building the mathematical formula to see which queries are more impactful, because I could never even prove if that formula is even correct or not. Approach was, but not the formula. So now, okay, now I have told you that what I thought of, but let's see what the actually problem would demand and what would work out. Let's think about the problem, and when I say think, we'll do two major things. One thing is that what can we do, other thing is what we have to do. Let's see, I take the same example nums, I take the same queries. Very carefully look at it, that the value 2 here at the index 0, it need to go down to a value of 0. It needs to go down, so from a value 2 it needs to go down to a value of 0. That is the requirement for sure. Now, which means that I should have to take at least these many number, at least nums of I number of queries I will have to take or have to be chosen. Again, words which are marked in golas as in circles are very important. So these nums of I number of queries will be chosen for this nums of I to go down. So in this case, for this 2 to become a 0, I will have to choose 2 queries, right? So now the question, okay, is that, okay, I now think that, okay, I have some number of queries. Firstly, the question is what all queries are even eligible to be chosen at this index, which is 0. So firstly, all the queries which are having their corresponding li and ri, which means the current index is in between that range. Obviously it's more of a generic thing, that it will be eligible, that these queries will be eligible to be chosen for this index I, right? So these are the candidates for me. But out of these candidates, only the required, when I say required, only the nums of I number of queries should be chosen. So for example, if I have 5 candidates for the queries for this index, but my nums of I is 3, so out of 5 candidates of queries for this index I will only be choosing 3 queries. Now the task will be again the same thing. How will you choose those 3 queries? Now to choose those 3 queries, let's take the exact same example. I will give you 5 queries. Now I will ask you, out of these 5 queries, which 3 queries will you choose? So I gave you these 5 queries. Take a screenshot, I pause the video and choose and answer me 0, 1, 2, 3, 4. Out of these 0, 1, 2, 3, 4, which 3 queries will you choose? Now, as you must have thought, I will choose query 4 for sure, then query 0, then query 3. Why I did not choose these two? Because of their impact. This query will have the largest impact. If I choose this one query, again, when I say choose, I am choosing a query to actually apply formula and use that query. I am not removing a query here. Removing I will do in the end. Now I'm only trying to say what queries I will choose to actually subtract my nums of I. Cool. So thus I realized, okay, I will choose this because it is pretty big. I'll choose this, it is very big. And again, this is my intuition says, okay, big thing, choose it. So that why big thing, choose it? Because this if I choose this specific query, and if nums of I is, let's say, 1 at here 1 so by just choosing one query, I will be able to get all these ones to 0. And thus, in my final answer, I will be saying that 4 queries I can remove. So that is the reason how I actually ended up choosing a query. So now we realized that we choose on the basis of impact. If you remembered, I also in the very beginning showed you that I also tried to judge impact, but I could not. I was building a function out of it, mathematical function, which was not applicable in that sense. Let's see how we'll solve it. But now we realize, okay, we are kind of going towards the impact. So we realize that for a specific L of I, I'm going to say L of I for the query itself, we are trying to choose the largest Ri, and that is the chosen. Out of candidates query, R of I, having the maximum R of I, will be the chosen one. Cool, because this will have the largest impact itself for us. Now you have realized what is to be done and how it is to be done. The most important question is, how will you implement it? And by the given examples, it's very hard to even think of how to implement it. So let's, again, this example, this is the example which I built from myself. So let's see how we will do it. I took a new nums array. Nums array looks like 2131. मकसद नहीं बोलना, your main aim is to get this to a 0 0 0 0. That's your final state. Indexes I will take care of, okay, 0 1 2 3. Now the queries which are given to you are these queries. Again, I'll put some indexes for you: 0 1 2 3 4 5 6. These 7 queries are given to you. Now, as you firstly very easily realized that for a specific, for a same L of I, you need to go and check for the largest Ri. So obviously I will sort all these queries, input queries, I have to sort it. Now the question is, sort on the basis of what? Should I sort on the basis of Li or Ri? Obviously, if you remembered, I will be iterating on nums array, and I told you I will land onto the index 0. For index 0, give me all the candidates, and out of all the candidates, I will choose some queries. Hold on if you don't understand this. So candidates can be determined by these. So this is a candidate, this is a candidate, this is the candidate. Now after getting all these candidates together, I can choose out of these candidates who will be useful to get this specific nums of I down to 0. Right? It needs to go down to 0. I know you don't have experience of someone going down, but this number has, because it is part 3. It has gone down twice already. Coming back, so now we realize, okay, we need to kind of bring these together, which makes obvious sense that I should sort on the basis of its start index. So I sort on the basis of its start index. And ultimately, when we sort by the basis of start index as a next parameter, ultimately it's also sorted by the basis of end index as the next thing. But start is primarily important because I'm going in from left and trying to make sure that this thing goes down to 0. Now, after doing a sorting of queries on the basis of simple start index, which is a simple, very simple basic sort, now the thing needs to be performed. Remember, maksad is to make it 0, but for that I need two things. One is candidates, the current candidates who, when I say candidates are the queries itself. Out of all these queries, which are the current candidate for the current ith index to go down to 0, out of these candidates, I will choose some specific queries, and that will be my chosen queries. which I will have to choose to get them to 0. And how I will choose most optimally? By taking the ones having the largest R of I, because largest R of I for if I go back where it is gone, okay, yeah, largest R of I will actually showcase me. Largest R of I will actually showcase me. It is the longest one so far what I have. Cool. Let's come back and let's see. So we realized that my queries, I am pointing to index j, and the current nums of I is at index I. At this index I, index is 0. Firstly, get us all the candidates. How I will get it? I will simply keep on iterating in my queries, and I will see, okay, his index is also 0, he's a candidate. Now, to put in your candidates array, there are multiple ways to put it here. You can put the index j also, but ultimately, if you remember, for me, I need what? I need this candidates also to be sorted. But Aryan, why sorted? Because if you remember, after putting all these candidates inside my this candidates data structure, again we will talk about that what this data structure can be. But after putting all these candidates inside this data structure, it needs to be sorted on the basis of some parameter such that maximum end should come at the top. I should be able to get the maximum. I should be able to, again, let's see, if I put all these three inside my candidates, then I should be able to query very fast the query which is having the maximum end index, because that is a good query for me. That's a chosen, that will go into the chosen query for me. So I want a data structure where I can put something, and that something, when I put it, should be sorted by its end index. So rather put the end index only. So I can put the end index only here. Again, you can put the actual index also, but here I'm putting the end value, which is 3 in this case, because that's obviously, but it needs to be sorted by descending order, which means it needs to be a max heap, or it can be a set also, which is reverse sorted, right? But you might say, Aryan, if I can use a set or not, that's a question. Set you cannot use because you can have same end values for two different arrays. If you choose index to put in here, then you can use a set. Elsewise, use a multi-set. Again, you have to sort it, you have to figure out that, okay, you have to use kind of like, if it is in Java, then you can use a tree map. By taking its corresponding frequency. If you are looking for more of a simplified approach, rather use a priority queue. Simply getting the maximum, again, max heap. So I'll put a 3, 2, 1, which means because of index 0, I simply iterated here, then I went on j here, then my j went on here, and then ultimately my j came here, j became 1, which is out of my range, so I should stop here. So far, in my candidates, I have these 3 candidates. Now, again, you will see the exact same code, that while my j is less than the queries and my my start value of the query is actually equal to I, simply keep on putting that query's end value inside my candidates and increase your j. Cool. Again, I'm showing you the snippets because this will help you to club the approach together in the end. Now, what is next step? Next step is, you have the candidates, but you have a corresponding nums of I value, right? You have to choose some values. And you have to only choose 2. So do one thing. Until your nums of I is more than 0, choose those candidates. So I know my nums of I is 2. I have to choose 2 candidates out from my candidates. And what I will choose? I will choose topmost one, which is 3. I will choose 3, and then I will choose 2. Now, the question again is, what this data structure should be? If you look back, you will realize, but you will realize this late. When I say late, you will realize that as you go on and move to the array, move in the array, you'll have to remove some elements from your chosen. Because if you have chosen something, again, this you will understand more in trial as you go ahead, but you have to remove some elements also from the chosen array. Thus, and what you will remove what is already gone, that you will remove from the chosen array, and what will be gone, which is having the lesser index. So this will be sorted by your simple smaller value should come at the top, which means it should be a simple mini heap. Now again, more you will get it by when I will complete the try run. Now you realize, okay, you have chosen 2 and 3. Thus, so far the number of queries which you have chosen has become 2 because you have chosen 2 queries. Now, ultimately, you are kind of, and you will see also, nums of I is more than 0, candidates is not empty, candidates peak value is more than equal to I. Obviously, that makes sense. It should be more than equal to I. Then simply increase your answer. Answer is the number of queries which you have chosen. And also make sure that in the chosen, add that candidate value and also remove from the candidate because it is no more the candidate. It's actually a chosen one. He's the chosen one. And also make sure to reduce your nums. Now, obviously, this is what you could bring out from your candidates. What if the candidate itself could not give you that many elements? What if this value could have been 4? I only had 3 elements in my candidates, which means my nums of I, what if it never became a 0? In that case, I'm screwed up because obviously I put all the candidates already in my candidates data structure, which was the max heap, and I completely made it empty and still it is more than 0, which means as a next step of this, I will have a quick check if nums of I is still more than 0, simply return a -1. This is after this step. Now, when this portion is done, you will simply proceed forward. When I say proceed forward, you will proceed forward to the next index because this has become simple 0 and that too by a simple greedy approach. Now, as you go on to next index, there is one small caveat here which I told you that I will bring up. That is that what if this candidate would also have one more range as 0 comma 0, and let's say I also put a 1 like this also here as an end value, and what if this specific value, rather than being a 2, it would have been a 4. So I would have chosen all 4 values, which means 2, 3, 0 and 1. Now as I shift forward, you will realize one thing. As I shift forward, the chosen of 0, again this value, what I indicate right here is actually the end index, end value, right? So for this range, if the end range itself is less than my current index, it will never be used in future. Make sense? If not, then look and repeat this same stuff which I told you earlier. So if some end value, if it is less than my current index, this chosen is never required or never applicable anymore. Why I said this is because if I come back and show you existing example again, I know I am kind of doing a context switch very fast, but it is actually a good problem. That's the reason. If I bring it back, now the question is that okay, for this one, you will simply say okay, Aryan 1 is there, I will put a 1 here, okay, then I will move my j, then I put a 3 here, I put a 3 here, then again I'll simply move my j, then it came to 2. So these are the candidates which I have. Now I ask you again, will you put some elements from candidates to chosen? The answer is no. But you will say, Aryan, I will put one candidate, right? No. You already have 2 candidates inside your chosen. So what is the need of putting any more candidates here? That is the reason. Before even again, you can put all these values, you can put the end values inside the candidates, but before even going on to this thing, that while nums of I is more than 0 and candidates not empty, remove from candidates and put up, before even going there, check if your chosen size is what. So I will check my chosen size and I will say my chosen size is 2. I already have 2 end indexes, which means 2 queries which are more than which have in end index more than equal to this his index. So for sure these 2 queries will cover him also. So no need to put any more extra candidates. So nums of I will become actually -1, which is less than equal to 0. Thus I will never be needing to come down to this specific loop. So here this piece of code will come here after your while, and before again he can come here also, no worries, it doesn't matter at all, but he will come before this specific piece of code where you are about to put something in your chosen, because chosen, as you put something there, your answer will increase. If the answer increases, you are trying to take that query and you have to minimize what queries you take, which means maximize what queries you don't take. So now again, let's proceed forward. This is my candidates right now. This is my queries right now. As I proceed forward here, okay, this is my corresponding I. Oh, here the index, firstly, the index is there. So make sure you put up 3 here. Okay, I put up a 3 here. Okay, makes sense. Then I checked. I checked. I already have 2 queries here. I already have 2 queries here. But even after I subtract, this will become a 1. Still, I need one more query. Even if I use both these queries, still I need one more query. So I will simply grab out maximum end index from my candidates and put up here. Okay, which means as I put up this, my answer will increase by 1 because I put up one query from candidates to chosen. It increased to 3. Now, okay, proceed forward. As I proceed forward, you will realize one thing, that as I proceed forward, this thing index end index as 2 will or should never be used, because if this value would have been 3, then you might say, Aryan, I already have 3 chosen queries, but this specific end index or end value is 2, which is lesser than 3, which means that whatever query this would be, it already ended at 2. So this can never be used for 3. So before even going to next index, make sure that any query which you have in chosen whose value is less than or equal to the I which you were at, again when I say I which you were at previously, make sure to remove all of them. And as you know that these queries will be like, let's say, end index or end values, so I need to remove the smallest possible. I'll check the smallest possible end value. If it is even less than I or less than equal to I, which I am right now, I will simply remove it because this will never be used in future. That is the reason you will see that if my chosen is not empty, I will peek and I will check if the value is equal to I. Again, you can put less than equal to also, but usually you will see equal to also works because you are going on to every index one by one. Because these all steps are happening for every index. Thus, it is safe to put it as equal to also, but you can also put less than equal to. That will also completely work. Then you will simply should remove it because this will never be used. Thus, if I go on to next value, which is 3 in this case, I will still have to do a peek, or I'll still have to look at my candidates because my chosen size is 2. So this is reduced to 1, but still I need one more candidate. So I'll get it from my candidates. I will put it to chosen. Now I'm good to go. I will increase my answer. Thus, ultimately, for this, I said that for this, I have to use 4 queries. How many queries were given to me? I was given 1, 2, 3, 4, 5, 6, 7, 8. I was given 8 queries and 4 I have to use for this specific nums of I. Nums array. Thus, my ultimate final answer will be nothing but the query length, which is 8, and the queries I had to use. Thus, 4 will be the answer of queries which I can actually leverage and don't, or I should not use. So I will repeat again. This is first snippet, second is this, third is again. You can put it also as 1, as this as 2, this as 3, this as 4, and this as 5. Cool. Let's see the code. It's exactly what I showed you. Just combining all the snippets. Firstly, I build a max heap of, again, this is a max heap of your candidates, min heap of your chosen, and then I will sort my queries in the ascending order, right? Then I will simply iterate on all the elements or all the indexes of my nums array. I will check, and again, this is the exact same thing. This is the number 1, this is the number 2, this is the number 3, this is the number 4, and this is the number 5, which I showed you just above in try run. And ultimately getting the queries dot length minus answer, because answer is the number of queries which I have to use. And ultimately, because you are iterating on all the indexes, but for all the indexes, ultimately what is happening inside in total is that you have this candidates, you have this chosen. You are simply putting queries inside this candidates. You are simply putting these queries from candidates to your chosen, you're simply removing your queries from your chosen. You only have Q queries, both are heaps. Thus, entire process, ultimately this standalone process will take Q log Q time, and also parallelly you are doing and iterating on the entire array, which is of n size. Thus, again, don't understand, like, don't make it like, okay, it is Aryan n into Q log Q. No, for every index, this in total for all of them combined will take Q log Q time, because this candidates and this specific candidates and what was the name, I forgot, fuck, how, yeah, candidates and chosen data structure, sorry for that, but yeah, this will ultimately be ingesting and removing queries, Q queries only. That's it, right? They're not dependent upon I. Now you might say, Aryan, but they're dependent upon nums of I, right? Nums of I is already being reduced with how many queries I have chosen, and if I am not able to reduce by queries size, I will have to return a -1. Impossible. And that is how I will be able to solve it, right? Thus, n plus q log q, and obviously you are using candidates and your specific data structure, so this will take O of q space. That's a worst case space. Cool. I hope you guys got it. If yes, then do smash like button. If you want problem 4, any one person can comment below problem 4. More likes, again, if you want problem 3, problem 1, problem 2, someone comment and others can like it or maybe comment it. More the comments or more the likes for a problem, we'll be able to bring it. Why I bought third problem firstly is because I usually see that there is very less engagement on problems which are very easy or very hard, so I just try to bring it. Again, this is actually a hard problem, but usually it is like after medium problem, which was question number 2, it was the next one. So again, if you want any problem, just comment it and other folks maybe like it or comment it. It's totally up to you. If you guys will say, I will bring it. And again, for you to say, like, many of you folks should be saying it. Cool, bye bye, take care. See you, goodbye, take care, and do let me know how you felt it. Bye bye.